Are you a business owner looking for real advice and input? You're in the right place. From concept to launch to growth, funding, and beyond. Welcome to Startup Hustle with your hosts. One once sold a business for $150 million. The other, the author of $1 Million Bedroom. Here are your hosts of Startup Hustle, Matt DeCoursey and Matt Watson.
And we're back. Another episode of Startup Hustle. Matt DeCoursey here with Matt Watson. Hi, Matt.
I'm so excited today.
Tell me why, buddy.
I'm going to lock your ass up.
Are you?
Yeah.
I don't believe it, man.
Yeah.
I think, but
Finally.
I know what I did today. I locked down a great guest to talk to us about a lot of really cool stuff. Yeah, with us today, we've got Harold Hess, who is the CEO and co-founder of Enduralock. Harold, what's up?
Hello, everybody. Happy to discuss the company and how we got here.
Yeah, well, yeah, we'll get all into that. So, for those of you listening, you know I like it when you're interactive. Go to Enduralock.com, ENDURA, lock.com, or if you're on the Twitters, at Enduralock. So, Harold, I'll continue to shout your accolades. So, your company does a lot of really cool stuff. You were demonstrating some of it prior to me hitting record, but recently you guys were a winner in the 2019 NASA iTech cycle competition. Is this true?
Yes, that was in July. It was in Mountain View, California, and we competed against a number of other companies. They chose three winners. We were one of the three.
Okay.
So what was the competition for?
It's basically they're looking for technology that NASA would be interested in, but that would also have other industrial applications.
And so it could be any kind of thing, or was it like a specific
it's
problem to solve, or was it just of any possible technology?
It's really any possible technology that could be of interest to NASA. So for an example, another competing company had a shuttle service, basically to take satellites from near Earth orbit out to geostationary orbit.
Okay.
That is so far away from what I do every day.
It's above your head for sure.
I'm going to get out the clicker.
Definitely
Where's
over
the
your
clicker?
head.
I need the clicker because the bad puns, we're already up to 3. Maybe I'll just roll without it. Normally I have a clicker. I penalized Matt for a number of different things. Did you find it?
I penalized you
wow.
today.
Dang it. This is what happens when you let your own technology get away from you.
So tell us more about what your company does.
Basically, what we have developed is very high-end fasteners, and essentially for the first time, a permanently locking fastener, meaning a nut and a bolt, that if you were to leave it alone, it's permanently locked. But yet with a standard off-the-shelf 6-point socket, you can unlock it, you can perform whatever maintenance is necessary, and then you can reuse it.
So it's not permanent.
Well, it is and it isn't. If you leave it alone, it's permanent. With a socket, it's not.
So, Matt, and I'm going to flex the limited construction and building knowledge that I have. But when you have a screw or a fastener, and it's easy to basically crush whatever you're trying to tighten it down on. So when it comes to certain things that you're building, that precision nature of like having the torque be exactly correct is crucial, right?
Yes, and when the socket is on, the nut is totally free spinning. So you can put an accurate amount of torque or preload, which is clamping force, onto whatever you're clamping. To give you an idea, in aerospace, the requirement for a self-locking nut is to withstand 30,000 cycles of vibration. And it's a pretty rigorous test. We took ours up to 300,000 cycles.
Okay,
wow.
So now, all right, so to give kind of the layman's version of that is, you were explaining a lot of and we're going to have to post pictures.
Yeah,
so
let me see your toys. I want to fondle your toys.
Well, hang on, Matt. Hang on.
Hand me your nuts.
So, oh, wow.
We have toys today.
And it's funny, Matt, because even though it won't be next to it in the feed, today was the episode about HR, and you may have just committed some HR violations.
That's all right.
But
I like your nuts. These are cool.
All right, give me the clicker. It already says 46 on it, and I feel like that's like very appropriate. So a lot of this is used in aerotech and space type technology, but back to what I was saying about being able to fasten things with precision. If you clamp something down a little too tight or at a wrong angle, it can change it changes the way the wind or the different forces is. That why is that so important?
Well, it's particularly important when you're clamping composites. And nowadays in aerospace, companies are moving more and more to using composites, meaning carbon. And with composites, if you have too much clamping force, you crack the composite. If you have too little, you have a loose joint, which will eventually fail. Another big use of these fasteners would be to replace castle nuts. A castle nut basically has has 6 slots in the nut, and you have a pre-drilled hole in the bolt. So you torque it and when you get to the point where you have the amount of torque that you want, you line up the slots with the pre-drilled hole and you put a cotter pin through it. But the problem there is with critical applications where an engineer might spec a very narrow range of torque because he wants a certain clamping force. To your point from earlier, you don't want too much, you don't want too little. Well, if you have only 6 slots, you may find that when you get to that part, it doesn't line up. And so what mechanics do is take the nut off and they try another nut. And they keep repeating that process until they can get things lined up. That's
because they can't over tighten it just enough to get the holes to line up.
exactly. That's actually an issue, for example, on the landing gear of the F-35. So with our fastener on a 1/2 inch or larger, we can have 50 gradations of torque. So more likely that the first time you put it on, it'll have the appropriate amount of torque.
Can I see your other nuts?
By the way,
Sure.
today's vocabulary test is going to be off the charts.
So these are, I guess like all little boys, I like, construction equipment, and these are fascinating nuts and bolts and screws and stuff you got here. Like, they're pretty cool.
So, by the way, as we get into the backstory of how this started, I'm giving you 3 guesses for what Harold did, what his day job was for a while. Go ahead.
He was a mechanic.
Wrong. Faster. You're running out of time. You have 3 seconds.
He was a precision grinder.
Also wrong.
He did CAD drawings.
Also
I
wrong.
don't know.
Harold is a neurosurgeon.
Oh,
Yeah.
what is that?
and never in my wildest dreams did I think that I would be selling nuts and bolts.
So how the hell did you get into the nut business?
Well, starting back in 2007, I was involved with developing a
I'm just kidding.
spinal
Fastener
implant.
business.
Basically, with a few other people, developed a spinal implant. FDA required that it survive 5 million cycles of compression, 5 million of torque without loosening.
Oh.
And on our original design, we had one fastener fail at 4.25 million. So I had to come up with a lock.
That makes sense.
And so I invented this lock and then realized it would have a lot of other industrial applications. So I kept the intellectual property separate, licensed it back to the spine company, and then put it into Enduralock.
And that other company is known as Spinal Simplicity.
That is correct.
And I believe that's one of Kansas City's top 50 funded
Yes.
startups.
Wow.
So, yeah.
As is Enduralock.
Yeah. There you go. Wow, look at that. This guy, he's just dominating.
Very cool.
So in today's lesson from Harold Hess, man, well, congratulations on the success that you found with both startups. Startups aren't easy. They don't come with owner's manuals. So just back to and still into the origin story here. So as a neurosurgeon, you saw a problem that needed to be solved, and basically what you described. What did it fuse vertebra? Is that?
It does. It takes the place of putting screws and rods in and performing a fusion in the low back.
Okay.
And with the implant that Spinal Simplicity has, instead of taking 3 to 4 hours to put in screws and rods, the last one that I personally did took 12 minutes.
Oh, wow.
And it's through, you don't have to open the whole back. It's through a small incision on the side, goes down a tube. It's all muscle dilation instead of cutting, so very little postoperative pain. In fact, in Italy, where we've been selling for a number of years, they let the patients go back to work in a day or two.
Wow.
Think about that, dude.
That's
You
pretty
have
cool.
you have 12 minutes to screw someone's spine together. Could you do it? I'm
I could
shaking
do
my
it.
head. Yeah,
Yeah, I
bet
could do
you
it.
could. You're
With
the
his help.
You're the last Yeah, I was gonna say, but yeah.
You don't trust me?
No. No. Is that a simple enough answer? Okay, so now this has still got to, we have to evolve this backstory a little bit. So now, all right, so you find this solution with Spinal Simplicity. How did you arrive at realizing that you had some kind of addressable market with these other things? Because none of the pieces that you have on the table I would want installed in my spine. They're pretty, they're pretty big and
That
they're
must
pretty
be tiny.
durable.
Right.
Yeah, like the big piece here, which is how big is this one?
That's a 3/4 inch.
Okay, I mean this thing is this looks
It
like
weighs a pound or something. It's heavy.
yeah, maybe this looks like something that would lock down like a connect two very heavy pieces of something together.
Correct.
So how did you evolve this into hey, maybe this is something NASA would want or the Air Force?
Well, it was actually a few months later after working on the spinal implant and inventing the lock that I looked at it one day and I said, well, wait a second, if I make some modifications, I could have a fastener that for the first time permanently locks, but yet is reversible and reusable. In the spinal implant, for example, the original design that's out in Europe, it's a one-way spinal implant. In other words, it locks in place and you can't really easily reverse it. With this, as we evolved the technology, you can use a normal socket just to take it off and then put it back on whenever you perform whatever maintenance you needed.
Well, the importance of that is if you've ever fastened two things together and they're locked, like you mentioned, it can be kind of a violent process to undo them. Yeah, I mean, so I would imagine if that's in your spine, that's bad. You get one try.
Well, and then it's totally different if you're going to ship the said thing to Mars.
Yeah.
Right? And it's got to withstand all the heat and vibration of that. That's a whole different set of
If we're going to get that
requirements.
listener on Mars that we've been looking for to
Yes.
complete the cycle, this is an important part of the process.
Maybe he could help us with the space station. We need the listener from the space station first.
Well, we're in the process right now of miniaturizing the fastener down to 4 millimeters in diameter, because that was at the request from the engineers at NASA Goddard, JPL, and Marshall.
And JPL's the Jet Propulsion Laboratory, right?
That's correct. I've had meetings at all three of those, as well as at NASA Stennis. Stennis does all the engine testing for NASA as well as for other companies.
Matt, currently not on my call list, NASA.
So you said 4 millimeters. How big is the one in the spinal?
That goes between 8 millimeters and 16 millimeters.
And how big is this?
That one is, I believe, 5/16. We've gone down to.
So the one in the spine is bigger than this?
It can be, yes.
Wow.
So Jill's sister has basically like a rod in her spine, and I think she would have appreciated your approach because it's invasive. They did have to cut her back open basically, and she can't bend over. I mean, I think that was part of it, but it was, I was talking to her about it when we were in Indianapolis over the summer, and they basically bolted a rod to her back.
Right.
So,
right.
Okay, so back to the startup nature of this. So here, Spinal Simplicity, you find a solution. Now you think that you're onto something else. How did you go about turning this into a business? Did you find other people to work with you? Did you fund it yourself? What's the story that occurred with that?
Sure. In the very beginning, I have two kids. Both have MBAs. And the three of us participated in University of Missouri, Kansas City's eScholar program, which at the time was close to a one-year program. So through that program, we developed a business plan for the fasteners. And we also had one mentor who was a former CIO, I believe, at BE Aerospace. BE Aerospace has since been acquired, but they were the major supplier of seating for commercial jets.
So that's who I need to address about why the seats are so small.
You might.
I got tall people problems, man.
Well,
I'm going to get those numbers from you after.
If I'm not mistaken, actually, FAA is doing a study shortly to look at how long it takes to evacuate a plane with the seats being as small as they are. And if it takes longer than it's in their manual, so to speak, then the airlines need to change things.
Oh, let's hope. Let's hope.
So let's hope those volunteers are a little slow.
Okay, so you guys go through a 1-year process, and and now here you go. Like, the thing is, these things didn't manufacture themselves. So how do you get about doing that?
Right. Well, once as we were going through that process, we were prototyping some early stage fasteners, and we were able to get a meeting with the standards fastener standards engineer at Spirit Aerosystems down in Wichita. Think of the standards engineers as kind of the gatekeepers. They determine which fasteners can be used by the design engineers. And so we met with him. He said that he hadn't seen anything like it in the industry, thought it was so unique that he thought we should go for a new National Aerospace Standard. He got us invited to the National Aerospace Standards Committee meeting, and that was about almost 4 years ago. And I got to know the standards engineers from all of the primes, so in other words, Boeing, Airbus, Raytheon, so forth. We eventually decided that we did want to go forward with establishing a new national aerospace standard, and we picked up sponsorship from Bell Helicopter and Boeing.
Did you patent this stuff along the way? Is that part of it?
Yes. For the fasteners, we're up to 9 U.S. patents issued, a Canadian patent issued, notice of allowance of a European patent, and we are patent pending on 24 others between the U.S., Canada, Europe, Japan, Australia, India, and China.
Okay.
Yeah, so how did you? What was the process to go about getting this approved for medical use? I mean, was that a long?
That was a long process with FDA. We originally submitted initially, and they turned us down, going through a 510K, meaning showing equivalence to another product. We spent a number of years selling in Europe, and then redesigned the product. Resubmitted. They wanted more testing, which went on for over a year, and then finally we got FDA approval. Since then, we've gotten a couple other FDA approvals on modifications of the spinal implant.
I can only imagine, like, as a business owner, like, you build this thing, you're so excited, and you're like, okay, now sit for the next 5 years while the government approves it.
Yeah,
like,
we've
oh
talked
my
about that.
God.
We've had some, we've been branching out the subject matter that we've addressed here, and we just did a episode with, man, I can't remember. Of course, they had basically reinvented the crutch.
Okay.
And had done a great job with it, but the background that founder had was he was a product engineer. He and his wife both were. So now, as a neurosurgeon, you understood the spinal part, but did you have to go through a whole process to, like, because these obviously need manufacturing and.
Right. Well, obviously you employ a team of engineers as well. So, you design with the engineers, and I designed with my partner as well, and we came up, with the implants. But, to put things into perspective, we started that in 2007, and we've had U.S. approval for approximately 4 years.
Yeah, and he was mentioning that and I didn't realize the complexity, because not only did they have to build the product, they also had to build machines to test them.
Correct.
So you just talk about, like, the things that you could forget or not know through lack of experience. You're like, hey, I'm going to make a bolt, but you might have to also build something to test the bolt and do a whole lot of different stuff. And that just sounds like.
Well, not so much of getting approved by the FDA is like the rigorous testing and proving all the testing.
Right, and it's more than that, actually, because it's you go through the whole process of getting FDA approval. Now you get your FDA approval, and you find out that insurance companies aren't paying for it because they say it's experimental.
So have you your solution for this for spinal, has it become kind of the industry standard at this point?
It's gradually getting accepted. I know that the leaders of the departments in spine at, for example, Cedar-Sinai in LA have adopted this. Rush in Chicago, Hospital for Special Surgery in New York. So it is getting acceptance throughout the medical or throughout the spinal industry.
Is the difficult part of that because, as a neurosurgeon, you're trained to do something a specific way, and now all of a sudden there's like a different.
Correct.
So you're just like, hey,
procedure.
this is what I know how to do, and I
Different
know
training.
this works, and
Right.
now I want you to do something different. The big question's why, right?
Exactly. You really have to make it apparent as to what the benefits are. And even when you make it apparent, it's hard to change somebody who's been doing the same thing for the last 20 years.
Yeah, especially if I hear you. And that's,
You get somebody who's like, well, I could use that bolt, but the surgery wouldn't last as long, and I couldn't bill as much.
I don't know. Is that really like?
No, actually, the coding is very similar. So
Yeah.
they just have more time.
I was going to say, I think you probably.
I can go golf sooner.
Yeah, that might be the case.
Yeah.
On some of that though, is I think that you're talking about you can invent a great product, you can bring a solution to market that makes sense, but you oftentimes have to go through an education process. It's like just because you've invented a better way to do something doesn't mean that people inherently or intuitively understand that. So, part of your plan needs to there's a market adoption that isn't always automatic.
Exactly. And the same is true in aerospace. If the design engineers are used to using certain bolts for years, it's hard to get them to change.
Right.
And
the same way you were trained. So there was I went in Indianapolis. There's a really cool airplane repair, it's like a mechanics school, and they've got all these airplanes in a hangar, and they're taking them apart and putting them back together. And the same way as a neurosurgeon, those guys are trained to do something a specific way, and if you change it, they're like, I don't know about that.
Yeah, exactly. Part of it comes down to also saving time and therefore money, and that's what at least in the industrial fastener world, that's what makes people change. The example that I gave before, as far as replacing castle nuts with this fastener, going from 6 gradations of torque to 50, you save time. You're not keep trying different nuts and waiting until one works, because the more time you spend, the more money you've spent as a company.
Is that how you sell that to the?
That's exactly how we sold it to Gulfstream. For
Okay.
example, Gulfstream wants to replace castle nuts and cotter pins across their fleet. Halliburton wants to use our fasteners because they can eliminate a mechanic. Basically, right now they need on fracking pumps and blenders, they need a mechanic on the top and a mechanic underneath to bolt everything down to the chassis. With our fasteners, they can eliminate the mechanic underneath and have that mechanic working on making more fracking pumps and blenders.
How much does that mechanic typically earn per hour?
I don't know.
I didn't know. That's a skilled trade.
Yeah,
so it's not cheap.
Right.
For
Exactly.
somebody like Gulfstream that is currently using Castle bolts,
nuts?
which is like a standard nut and bolt, but it has a cotter pin that goes through the nut, right?
Right.
In layman's term for me. How much difference is the cost to them? Like compared to like what I have in my hand here, which might be a replacement.
Well, the product that you have in your hand is actually a product that we designed over the last 8 months that employs a stamping and forging process. So with a stamping and forging process, we can get the cost down to single digits. So you'll find that it's really not a huge difference, in price between what they currently use and these fasteners.
So would this be like $5 or something? Is that what
We
you're
could,
saying?
at higher quantities, we probably can get it down to that level. Yes.
Okay.
At quantities of, let's say, 10,000, we're probably looking at a price of around 8 in
Okay.
that range.
So how much do you sell the ones for that they use in the Spinal? What does one of those cost?
I believe that the list price is 15,000.
Wow.
$15,000?
Yes.
But is it much different than the $8?
I hope so.
Oh, it's much more. The only similarity between what you have in your
It can't
hand.
be that different.
Yeah. The only
Probably made of titanium or
It is.
something.
It is made out of titanium, and
Okay.
there's a lot more to it than just a nut and a bolt. It's a pretty machine product. very different than just looking at a nut and bolt.
So with something like this, you were mentioning, vibration and different stuff to test. How do you test something that would go in someone's spine? There's not much margin for error there.
There's a whole bunch of tests that you have to perform, but basically they have tests that you implanted in a, shall we call it an artificial spine, and then the machine does compression, the machine does bending forward and backwards, torque, so forth.
Okay, so recently you were chosen to represent the United States at the Global Entrepreneurship Summit in Hague.
That is correct. That was in June. We were chosen as one of the representatives of the U.S. And I went to the Netherlands and had a great time meeting entrepreneurs from all over the world.
Is that something you applied for, or were you selected?
I was asked at, we were also part of the South by Southwest NASA competition, and I was asked by one of the State Department officials at who was there that we should apply.
Harold's super connected. That's what I'm gathering. He knows people in the State Department, NASA. But no, I mean, that's got to be an important part of what you're doing. I mean, someone has to make a decision on these things. And it seems, one of the things I always talk about with startups is understanding your path to revenue. It seems like you've chosen some things that have a very long, I'm not going to even say a path, they're like a highway to revenue, because dealing with the government, that's not fast to get them to adopt anything and approve anything either.
No, it's a long process. We've been working, for example, on a joint development project with Superior Energy for offshore well completions. That project's been going on for approximately 2.5 years. Testing was just completed. So they plan to commercialize in the next couple months.
So that's what has to make this so hard, because you go through all that work and they're like, oh, we want $5,000 worth of your fasteners. It's like, oh my god.
Yeah, but the thing is
like it's got to be a much bigger order.
Yeah, but Matt, when you're building like,
right.
How much you said F-35 earlier,
right.
a fighter pilot or fighter plane, like how much does one of those cost? A lot.
Yes.
And if if there's a piece that makes that better somehow or somewhat, I don't think they're really like, you know what, I'm going to need 8% off on that order. I mean, am I right about that? I mean,
yeah, you are. I mean, again, if you can save them time, you save them money, and that's.
Or
and
if you can give them performance that
right.
is not available somewhere else, right?
Exactly.
And these other materials too, like we mentioned, like we were just talking about carbon fiber and titanium and stuff. Like these things aren't cheap.
Yeah. In fact,
so ruining panels and stuff like that, not good.
To give you an idea, one of the components that we make for Superior Energy uses a special alloy of titanium. A 5-foot bar, 1-inch diameter, which would give us 50 springs for the fastener, costs $1,750. So that gives you an idea of and that's a special alloy.
I feel like when they attached Wolverine's claws, that Enduralock got the contract to hold those down, because those had to be stable. I mean, you don't want any play with those, right?
So do you make some of these out of like pure carbon fiber or other?
No, we've made them purely out of metal so far. We are exploring potentially going into plastics as well.
Okay, so you're here in Kansas City, right?
Yes.
Are all your employees here?
No, I have 2 employees here in Kansas City. I have my VP of engineering out in LA, and then we have 2 part-time engineers, one in LA, one down in Houston. The one in basically the part-timers have between the 2 of them probably 30 years of experience in aerospace fasteners, and my VP of engineering was VP of research and development for Lisi Aerospace.
So where do you make these then?
We make them using contract manufacturing here in the U.S. We've also made them in Taiwan.
Okay.
It really depends on the customer.
What's been the challenge with manufacturing stuff?
Do you have like hundreds of SKUs?
We have, obviously, it's many different sizes, many different materials.
And that's got to be a big part of the complication of manufacturing.
Right, but we don't stock them on the shelf. So in other words, it's
meaning there's no SKU amount.
Yeah,
right.
I mean, like Halliburton actually sent a request for quoting 2 weeks ago for 18 different size fasteners to be used on fracking pumps and blenders.
So you don't really have any like standard sizes that you build in stock?
Not in stock, no.
I think what he's also saying is you don't go to Lowe's and buy these.
Well, yeah, I get that, but
Do you remember what SKU stands for? We had a previous.
oh,
Yeah, we had a previous.
we need to ask
vocab-
him that.
I don't actually know.
You know, it's funny. I didn't know after running a chain of retail stores. Stock keeping unit.
Oh.
SKU. Yeah. I don't know. It's a weird thing. Okay, I want to go back to the Global Entrepreneur Summit for a second because I think that's pretty cool. So, can you tell us a little about the actual summit? Like, who else was there, and like, is that something that you're trying to win? Is it something that you're just representing?
You're interfacing with other entrepreneurs from numerous countries around the world. Each year it's hosted by a different country. This year it was hosted by the Netherlands and the U.S. The year before was in India. But it's also an opportunity to interface with potential investors. And in my case, a few months earlier, we had entered, independent of the Entrepreneurship Summit, we had entered a Shell oil competition, which we won. And so while I was at The Hague, I also met with a team of engineers from Shell Oil, which was very exciting. And that the corporate challenge that they had is how do you improve safety through less human interaction with offshore wind farms. You can imagine if you have this wind farm in the North Sea where the ocean is pretty rough, and you have maintenance boats that go out there and have to maintain these windmills.
You don't want the blade falling off, man. I think that's what I'm hearing.
Yeah, you don't.
So Harold, this all sounds really expensive. Have you sought outside investment? Is this something you funded? And if you don't feel comfortable talking about it, but that's always a hot topic with any of our listeners or people that come in here is like, how do I fund my dreams?
Sure. I mean, initially I put money in myself. Since then, we've had individual investors that have invested in the company. We have a round of investment open right now, as an example, for qualified investors.
Okay. So sometimes are the people that invest in what you're doing also the people that are your clients?
It hasn't happened yet with us, but you do find that you have corporate investors. So, for example, Boeing has a venture arm. Lockheed Martin has a venture arm. So they look for companies where they'll put some money into the company, and then at some later point, if the company is doing well and they're interested in the technology, then they acquire the company.
Yeah, I was going to say, is that the exit path, and is that the likely outcome with the company is to seek an exit, or is this something where you guys just keep making nuts and bolts and because once you've made this technology, it exists, and then it's not nearly as expensive. It's the creation of it and bringing it to market that's the most expensive part, right?
That is correct. We will eventually exit either more than likely through an acquisition from another fastener company, a larger fastener company, potentially IPO. The thing that's so unique about these products is they have application throughout every industry.
Right.
So we keep it's almost like every month we're finding new applications or new interest from other industries. I mean, so far, as I mentioned, we've been working with Superior Energy, with Halliburton on the oil and gas side, Gulfstream on the aerospace side. Now NASA, they have a few different projects that we're looking at doing with them. But another example is we have somebody that's very interested in licensing the product for Australia. He has a manufacturing plant in Australia, and he currently sells to the mining industry.
Yeah, that was my next question, is also licensing the patent technology. Does that become a revenue center for this? Or?
It does. It does, because basically then you're just getting a percentage off of gross profits, or gross sales, I should say. We have another individual that I've met with already who sells fasteners. He's a major supplier of fasteners to the Indian Space Agency as well as Indian Defense. So we have meetings that are being set up in India in the month of December for me to meet with those organizations. That would again be a license. The fellow who has the Australian company also has a company that sells parts to the racing industry. His background was actually racing. So we will be exhibiting with him at Performance Racing Industries, which is the annual show for race car enthusiasts.
Well, that's what I was going to ask you, is would it make sense to use these on just a normal car?
You can if you can get the price down. And that's the reason why we went to the forged and stamped version.
Which is what I have here.
Correct.
Like this, to me, this looks like a bolt you would find at Lowe's.
Yeah,
I mean,
agree.
from the quality.
Right.
I mean, I don't
Well,
know.
will
I'm
you
not
show
I'm a
him
novice.
the other one?
Like this doesn't look
thing
like
over
a
here.
titanium bolt to me. It looks like a
So Matt, this is the
hardware
one.
store bolt
This is the one
with a
you
totally
need
different
to-
fastener.
This
Right.
is the one that I thought was interesting because it's got like a swivel pivot thingy.
Right. We designed a new
Ooh, fancy. Let me see.
access panel fastening system. With when you have access panels on planes and helicopters, for example, you want to be able to access the hydraulics, the fuel lines, so forth. So you have these panels with bolts all along the rim of the panel, and in aerospace they want to always retain the bolt to the panel because you might have different length bolts at different points of that panel. It's not hard when you have a panel that's only a few feet in size. But for example, on the belly of the plane, you can have a panel that's 15 meters long with a few hundred bolts. Well, as the mechanics go to line everything up, you can well imagine that some of the bolts are not going to line up properly. With current nut plates, the nuts cannot swivel or tilt. So if you have bolts coming in at an angle, they won't engage. So that means more time that the mechanics have to try to line things up better and so forth. Well, with our nut plate, we have a significant amount of play where the nut can tilt because it's spring-loaded, so it can engage from a bolt coming in from an angle. That would save a tremendous amount of time, and just a few weeks ago when I demonstrated that to all the standards engineers at the National Aerospace Standards Committee meeting, there was interest from essentially every prime.
So, and once again, if you want to check out Enduralock, go to enduralock.com. And for those of you that are not listening via our YouTube channel, I've been holding some of these things up to the camera, but I think this one's pretty cool because, and I'll kind of dumb it down. If you're ever trying to put a screw into the receiving piece, the proverbial male to female piece, if you don't hit the right angle or you don't get it threaded correctly, it can be a mess. And that's what this has, like a little swivel pivot, and it's also got some push to it, which is basically what you're saying is a lot more forgiving for the recipient that is screwing it in.
Exactly.
Yeah.
I mean, it'll save time,
Yeah.
therefore money.
And I'm assuming when you mentioned the belly of an airplane, that if you get one screw wrong, that can mess up. You just took the time to put in 200 screws,
right.
And getting one of them wrong could mean starting over, right?
It could, exactly.
The level of precision has to be so high with a giant piece of sheet metal or whatever with all those holes in it.
Right, and the thing with this nut plate is it self-aligns. So as the mechanic starts putting the bolt in, it will align the plate.
Yeah, and that's the point. It's like you talk about that time. It's just like I've done that. You're just like, I mean, it can be something simple like trying to put a doorknob on.
Oh yeah.
Right.
And now man, if you've ever run a screw into something and like messed up the thread or like I don't know. I've probably made every construction error that is possible to be made. So, well, this is all really interesting. So, and as we kind of round out today's episode, first off, you can check out today's episode and see our thrilling and very, very demonstrative examples of this, which is basically me holding it up to the camera on YouTube. We'll also be posting some pictures of what Enduralock builds, and you can check those out at Startup Hustle Podcast on the Instagram. So as we round this out, we end the episodes with what we have now lovingly called the Founders Freestyle, and we just kind of walk down the line. And Harold, what most will use their freestyle time for is giving advice to up-and-coming entrepreneurs, but you can say about whatever you want to the world. So we kind of hand over the mic to you, and it's been how we've been closing things out, and it's been quite interesting and fun. So,
Well, one bit of advice that I would give to other entrepreneurs out there is look at technology in one industry and see in your mind how you can apply it to another, because that's where you can really make a disruptive change to another industry. Don't limit yourself just to whatever your focused industry is, because when you start applying it to other industries, you all of a sudden find that there's nothing like it out there in that other industry.
Mr. Watson.
I think today's company is a great example of somebody that is in a profession, in an industry, doing their job, and they see a problem, and because of their industry knowledge, they're able to use that to solve a problem, right? So, you figured out, hey, we need a better fastening system for spinal cords and whatever, and you're able to see that problem and solve it, right? And that's where the best startups and entrepreneurs come from, is they're working in an industry, they see a problem that only they understand because they're working in that industry, and they go solve it. Where you have a lot of people who are like, I want to start my own business, but I don't know what to do, right? Which is a whole lot more difficult. But if you're in an industry and you see a problem you can solve and you go solve it, that's awesome. And it's great, like you said, you were able to take this problem and then figure out how to solve it in other use cases, which is great. And to me, what's so cool about this is it seems like such a simple thing, like we've invented a butter nut and bolt fastener, right? Like that is so cool. You would have thought that we'd already invented that.
Like
but
40
you have
years ago, right?
You have
Yeah, yeah.
reinvented
Yeah.
nuts and bolts and fasteners, which is so cool. And I'm just looking at these things and I'm just kind of puzzled at how they work. You're gonna have to give me more of a demo of this.
Sure.
Because the mechanic side of me is like, how does this thing work? But I just think it's so cool. It seems like such a low-tech thing, right? But has such high-tech use cases.
Right. It's
Which
a
is really
relatively simple design.
Yeah, it's so cool. I love it.
Yeah, and for those of you listening, once again, thank you. I'm going to stay in line with you guys here as we round this out, and just like, I love repurposing any kind of technology, and the R&D cost of what you're doing drops every time you find another use case for it. And Harold, how big is the fasteners industry? Because it's huge.
Currently, it's about 88 billion,
Right.
and expected to rise to 130 billion in the next few years.
That's insane.
Yeah, and so, but would you have guessed that, Matt?
No.
Yeah, so here you are. You're building something else. Harold starts as a neurosurgeon, and now is going to become a titan in the fastener industry.
The master of nuts and bolts.
I mean, just as an example, one thing that we're working on right now is scaling the fastener also larger to 2 to 3 inch diameter bolts. The purpose being for pipelines.
Yeah.
Currently, there is no locking bolt for pipelines. It's just a nut and a bolt. If we can scale this up, we can lock it. Therefore, we can reduce oil spillage. And there are, we estimate, over 2 billion bolts used in pipelines around the world.
And eventually they fail.
Yes.
And you get a leak.
Yes, exactly.
Well, you heard it here first. So go to Enduralock.com, check out what they're doing. Harold, I want to wish you all the best of luck. I think this is really cool. Thanks for coming in. I know between fusing spines and changing aero technology, you're a busy guy. I think this is great. I want to wish you all the best. By the way, it's spinalsimplicity.com, right?
That is true.
Yeah, so you can also go check them out.
And thank you to both of you.
Yeah,
thank
pleasure
you.
being here.
Very cool. Thanks
for coming in. See you next time.